Alright, this video is going to be talking about SOHCAHTOA. This is a trigonometry type of acronym. So let's look at the first part, SO. SO means that the sine of the angle equals opposite over adjacent. Okay? And CA means that cos of the angle equals adjacent over hypotenuse. And lastly, TOA means tan of the angle equals opposite over adjacent. So let's just put a slash here to keep in mind what this actually means. Okay, so looking at sine, what if we wanted to rearrange this somehow so we got the angle? Okay, so let's imagine this. If we were to divide sine of the angle from both sides, you wouldn't be able to actually get the angle out. Okay, it's not sine times angle, it's sine of the angle in brackets. Okay, this is a better way of writing it because you actually understand what's going on. The tan function is doing this to the angle, or the cos function is doing this to the angle, etc. So how do we inverse this? How do we find the angle of the sine function? Assuming you have opposite and over hypotenuse, how do you find the angle? Well, the opposite of doing a sine function is doing an inverse sine function. Okay, sine to the negative 1, bracket, sine of the angle. And if you do it to the one side, you have to do it to the other side. Sine to the negative 1, opposite over hypotenuse. Okay? And what our rule is going to say here is that sine to the negative 1 cancels with sine. So what you get left with is the angle equals sine to the negative 1 of opposite over hypotenuse. Okay? And we can do the same thing with all of these functions. So cos to the negative 1 of cos of the angle. And if you do it to the one side, you have to do it to the other. Adjacent over hypotenuse. Okay, and more simply, the cos to the negative 1 and the cos cancel. So we end up having the angle equals cos to the negative 1, adjacent over hypotenuse. And lastly, we can do this with the tan function, tan. So this is like adding to one side of an equation, you have to add to the other. If you subtract from one side, you have to subtract from the other. It's the same sort of situation. It's just the inverse of the tan function in this case while I'm writing it. And if you do it to one side, you have to do it to the other. Opposite over adjacent. Okay, this tan to the negative 1 and this tan cancel. So the angle equals tan to the negative 1 of opposite over adjacent. There you go. So that's how you solved for one side of the two equations. So there's actually two equations that line up with SOHCAHTOA, and both of them have to do with sine and opposite over hypotenuse, or cos and adjacent over hypotenuse. So there's two equations that line up with each part of SOHCAHTOA, and each of the two equations are important, or you can remember the rule of how to get from one to the other. Okay, let's look at a triangle. Now we can only use these rules if the triangle is a right-angled triangle. And let's say we have C, A, B. Okay, so C, B, and A are all sides, and the angle is one of the angles. Okay, if you know one of the angles, you could find the other one, but we're just going to pretend we only know one. Okay, in this case, if we have any two of the 4 letters here, we can solve for the other ones. Okay, if we have B and A, and we want to solve for the angle, how do we do that? Well, this would be a tan function. So tan to the negative 1, because we remember that the angle equals tan to the negative 1, and what was it again? Opposite over adjacent, right? It's opposite over adjacent. Opposite side, this is a longer line than this line, so it's the opposite side. So B ends up being the opposite side, okay? So B over A, and adjacent is the closer one. The hypotenuse is always adjacent, but we call it hypotenuse so we don't have to worry about it. So we have the angle and we have A. So now I'm thinking about this, and I always write out SOHCAHTOA so I remember what lines up with what. Tan TOA. There you go. So if I've got A, and we try to find which side we want to go for, let's go for C. Okay? So we're looking for the hypotenuse. So now it's going to be a little bit more tricky. So we've got the adjacent side, and we're looking for the hypotenuse, and we've got the angle. So let's just write it out first. Cos of the angle equals, what was it? Adjacent over hypotenuse, right? Adjacent in this case is A over C. But we're looking for C. So how do we get C to the other side? Well, we multiply both sides by 2. Right? Multiply both sides by 2. We have 2 cos theta equals A. But we don't know A, but we know this angle. Oh. Sorry, why did I multiply by 2? Multiply by C. There you go. Multiply by C. So we know theta, so we need to get theta over to the other side. So, but at this point, it's already multiplying by something. So we wouldn't be able to use that tan to the negative 1 or the inverse function of the cos. We can't use cos to the negative 1. What we have to do is we have to divide both sides by cos theta. Cos theta. Okay, so this one cancels this, and we end up with C equals A over cos theta. There you go. So now we've solved for 2 of the sides, and we actually solved a harder one than we could normally. So if we solve the other way around, let's solve for, let's try to go with a sine function this time. So let's solve for B, and we have C, and we have theta. So if we have C and we have theta, let's write it out. Sine is what? Angle equals opposite, in this case is B, good. We're looking for that, over hypotenuse, which is C. We have the angle, we have C, but we don't have B. We're looking for B. How do we get C to the other side? Multiply both sides by C. So we have B, and we have C times by sine theta. There you go. So B equals C sine theta. So we solved for different sides and sort of different ways. And you can just use algebra to move these things around. And if you have 2 out of these 4 letters, you can find any of the other ones. Okay? That is SOHCAHTOA.